Hello, ESS folks, it's Miss Lenorovitz, and in this video I'm going to give you an introduction to exploring fluxes in the carbon cycle. So you're going to come to find out that fluxes give you an idea of how much carbon is moving from one location or one reservoir to another, and whether the movement is equal in both directions, which would mean it's balanced, or whether it is unequal, meaning that it's unbalanced. So you're going to start off by pulling from your knowledge that you already have about the amount of carbon in each reservoir. So you're going to be working with an amount called a gigaton, which is 1 billion tons. Your first step is you are going to be looking at all of the carbon that is stored on Earth in gigatons, and you're going to be expressing it as a percent. You have directions in your work to guide you through this, but remember that percent is the part of the whole. So the first step you'll need to take here is adding together the total amount of gigaton in the reservoirs. And then you're going to, for each reservoir, divide the part represented by that reservoir by the whole. And once you get that answer, you're going to multiply it by 100 to turn it into a percent. From there, you're going to do a little bit of coloring just so that you can symbolize those different locations. So on the very last page of this document, we'll look in just a moment, you're going to see a page of squares. You're going to color in yellow the squares that would represent, out of those 100 squares, that would represent the atmosphere. You will color in blue the squares that would represent the ocean. In green, the squares that would be represented by vegetation and soils. And in red, the squares that would be represented by fossil fuels. So on that very last page of your document, you're going to see a series of unlabeled squares. There are 100 total here, so you're going to be translating 1% equals 1 square. Once you've done that and you've cut them out, you're going to be placing those squares into their representative reservoir or location. Know that later on you're going to need to relocate some of those squares, so I would keep this page to the side with your squares placed on it while you're working on the other aspects of this assignment. Your next step, once you've done those initial calculations, is going to be to learn a little bit more about what a flux actually is. So you're going to be learning about fluxes in general and what balanced fluxes are. Explain that in your own words, and what unbalanced fluxes are. Also explaining that in your own words. From there, you're going to be looking at representations of the actual fluxes in Earth's atmosphere. So we're zoomed in to think about carbon that's entering Earth's atmosphere and carbon that's removed from the atmosphere. So in your table that you're looking at here, you're going to see the processes that are listed here. So remember, those are the steps that can take carbon from one reservoir to another. In the next column over, you're going to look at annual flux. So annual flux is gigatons of carbon, so billions of tons of carbon every year. Underneath that big heading, on the left-hand side, you're going to see amount of carbon that's removed from the atmosphere. So these are processes like photosynthesis in plants that can take carbon out of the atmosphere. For photosynthesis, that would be through carbon dioxide. All of the fluxes that require a removal of carbon from the atmosphere are indicated by a down arrow here. The column on the right-hand side of that represents fluxes that add more carbon dioxide or carbon in any form to the atmosphere. So for example, the combustion of fossil fuels annually adds about 9 gigatons or 9 billion tons of carbon every year. Notice that all of the fluxes that are adding carbon are represented by an up arrow. So you're going to be adding up the total amount of carbon that's taken out of the atmosphere and the total amount of carbon that's added to it. From there, you're going to do some math to calculate the difference. And then using your understanding of balanced and unbalanced fluxes, you're going to identify whether this one is balanced or unbalanced. From there, you're going to be doing a little more thinking about our actions as humans in terms of our combustion of fossil fuels. So you're going to be thinking about what would happen if combustion was not part of the processes that was adding carbon dioxide to the atmosphere. Then would the fluxes be balanced or not? From there, you're going to be relating the amount of carbon in gigatons into another concentration measurement that we've been using, which is parts per million of carbon dioxide. So you're going to use your answer from question number 7. So in this case, you're going to use a value calculated previously in order to calculate the rate that carbon's added to the atmosphere in parts per million every year. From there, you're going to explore a website that's going to take you outside of the assignment. This is linked on our weekly learning plan, and this is going to take you to the National Oceanic and Atmospheric Administration. When you get here, there's a lot of data that's on this website. You want to go where probably will land you in Mauna Loa, Hawaii, which has been the longest recorded location of carbon dioxide levels in the world. But you're going to want to look actually at global. And when you do that, if you scroll down, you're going to be seeing a lot of information here. You'll want to look at it again on the date that you look because these numbers do actually change. So you can see here the concentration in January of 2022. You can compare that to January of 2021. You can also see what's going on monthly, and you can also see what's been going on over a longer period of time. From there, you're going to be doing some math to calculate what amount of carbon dioxide would be added to the atmosphere if it continued to increase at the same rate that you calculated right here for 10 years, and if it continued to be added at the same rate you calculated here for 100 years. Make sure for any of the calculations you're doing in this whole assignment that you're showing all of your math, all of your work and thinking there. From there, you're going to revisualize what carbon will look like on Earth 100 years from now. So you're going to be using those predictions to adjust the predicted percent of carbon stored in 100 years. Really, what's going to be different is you're going to alter the amount of fossil fuels that are still unburned, and you're going to alter the amount that's in the atmosphere and then recalculate your percentages. Again, you want to make sure you're showing your work. And then you're going to go and actually relocate some of those squares in the very last page. So you'll recall back at the very beginning, you had a certain number of colored squares in each one of these boxes to represent the reservoir of the atmosphere, the reservoir of vegetation and soils, the reservoir of fossil fuels that are still unburned, and the reservoir representing the oceans. You're going to adjust the positioning of those squares without changing their color to their new location where we anticipate they'll be 100 years from now. Once you've done that, then you can go ahead and attach those squares directly to your page. From there, your very last step is going to be to write an argument in which you're analyzing the information that you just worked with to explain what will happen to the amount of carbon dioxide in the atmosphere over time. And like any good argument, you're going to make a claim, and then you're going to use evidence to support your answer. There are multiple pieces of vocabulary you want to make sure you include in here as well. I hope you have fun exploring the idea of fluxes. You're going to use this assignment for the next work that you're doing with your carbon model. So make sure you not only give this good attention, but that you hold on to it as well. 1, to show it to me for a completion grade, but 2, so that you can use the data from this activity for your next assignment.